All right, if this seating arrangement doesn't work, I'm totally fine going back to rows or whatever. So this is like your one chance to be able to work in groups and, learn that way. We are moving on to unit 4. So it's a kind of weird. We went 1, 2, 4. Unit 3 has been pushed to like the end of the school year. So like more around May. There's just certain things that, math always has a lot of content to get through, but there's just certain things that are like really, really important. And unit 4 is one of those really, really important things. So it's about functions. The goal today will be to look at some fun functions around us and try to describe them. So you'll know that you're successful if you can explain when a relationship between two quantities is a function, if you can identify independent and dependent variables in a function and use words and graphs to represent the function, and making sense of the descriptions and graphs and explain what they tell us about situations. So I'm recording right now. I'll link it in the slides, just like always, because again, math always has a lot more standards than say like your English class does, for example. So we always have a lot to cover. Anytime you're absent, the expectation is that you are making up the lesson, whether it is watching the full video, Remy, and Parker too, but you were talking while I was looking at you. So stop that. Anyway, whether it's watching the video, taking the notes from online, that's the expectation. So just like you noticed with those binder check grades, that really cushioned your grade. I haven't put anything in the grade book yet for the unit 2 test. So that will take me probably up to 7 days to grade. And the first time around, I graded it really fast so that you would have that opportunity in order to work in groups and, learn from your mistakes. I think that went really well. I did not have as many people have trouble finishing the test as I did like the first day around, but that's also another thing too. Like in the real world, you don't get extra time. If you don't meet deadlines, whether it's at your job, whether it's like paying your bills, whether it's for like a court, I don't know, you feel those consequences. It's not like you're late on your water bill and they give you more time. Like, no, they just shut it off. If you're late on your house bill, no, they just evict you. Like there's not a million chances. So like really consider that. You don't get extra time. When I say it's due at the end of the hour, it is due. All right, but I digress. So back to unit 4, lesson 1, you do have a puzzle piece. It is available even now, starting today. Moving forward, we as math teachers are trying to keep them around like 5-ish questions. So hopefully this unit around will get a lot more completion. But regardless, it's on you. If you're not practicing, then I'm not surprised that you're doing bad on the quizzes. If you're not practicing, I'm not surprised that you're doing bad on the tests. Like it's all a skill that you need to practice. It doesn't just come naturally all the time. So just reminding you, I'm probably not going to talk about binder checks again. I put those scores in. If you were wanting to resubmit, you have to use your words and say, Miss Medina, I'm ready for my binder check. And as long as I'm not in the middle of teaching, I will check it and update your grade. I will do that before the end of this month. All right, because again, deadlines, they're a real thing in the world. You have to meet them. And I think a month deadline is very generous. So if you're wanting to resubmit for that 50-point binder check, you have to show me your whole binder check and I will update your score. All right, so we're in unit 4 now. We're going to have a quiz over lessons 1 through 5. I don't know when exactly, but I would imagine sometimes next week, but we will see. So any questions? All right, so then on to the note sheet. And then I forgot to make a list of people that were absent for the retake. So I'll just start pulling people that were absent for the retake next week, if that applies to you. Today we'll just keep moving forward. All right, so the front of your paper is actually the side with the bagels. My TA put it on the wrong side, sorry. the holes, I mean. So the page that you should be looking at first is the one with the bagels on it. So here's your warm up. A customer at a bagel shop is buying 13 bagels. The shopkeeper says that would be $16.25. Jada, Priya, and Han, who are in the shop, all think it is a mistake. Jada says to her friend, shouldn't the total be $13.25? Priya says, I think it should be $13. Han says, no, I think it should be $11.25. Explain how the shopkeeper, Jada, Priya, and Han could all be right. All right, and to kind of help you with that, there's a table with the best price options for the bagels. So just kind of think about it with your group. Look at it first alone for a minute. How could they all be right? Is your warm up. All right, so is it possible for all of them to be correct?
Not that one.
There must be, because it says explain how they could all be right. So there must be a certain way. Anemone, please put the book away. Hey, you listening? Anemone? Can you put the book away? All right. So can someone explain to me how the shopkeeper may be right? Parker?
She just counted up 16 single bagels. Or no, 13 single bagels.
Okay, so 13 bagels times what's the price for one bagel? Is that the best deal for 13 bagels? No, and sorry, I need a calculator. It's the morning, I need to be sure I'm right. Okay, yes, so that would give you 16.25. So that must be what he rang up in his register. Good. How could Jada be right? Riley?
She's thinking of ordering 2 of the 6 bagels and the 1 bagel.
Okay, so 2 6-piece bagels, I guess you could say. And then what was the other one?
Just the 1 bagel.
Okay, so 1 times the 1.25, which gives you 12 plus, oops, I don't know why I'm doing 0.25, hold on. Which then once you add that together, you get 13.25, which is what Jada said. Good. What about Priya? How could Priya be right, Lauren? So 1 9-pack, which is $8, and then what'd you say? 4 singles. So $8 plus 4 times 1.25. Good, sorry. Since this is my first time doing it today, I want to be like 100% sure. All right, good. So that makes sense. And then lastly, how can Han be right? Parker?
Yeah. At the end, 12 bagels with 1 single bagel.
And the 12 bagels sell for $10. So that's 10, wait, hold on. I should have did 1 order of 12. Okay, so then that's $10. And then plus the 1 single bagel. And that's how we get 11.25. So really, what price should they be awarded? Hans, Priya's, Jada's, or the shopkeepers? Hans, I think. Because why do you have specials on multiple bagels if you're just gonna always charge someone the full price for the 1 bagel? All right, I could see why the shopkeeper would want to do that, but if you're having special prices, like you should honor those special prices. So yeah, Han really had the best deal in mind. Now, as far as completing the table, if you haven't done that yet, this column, or I know yours is like the other orientation, but the other column is for the best price. All right, so fill that out if you haven't already. Like if I'm buying one bagel, what's the best price breakdown? I'm buying 2 bagels, what's the best price? So fill that in. I'll give you about a minute-ish. How much would it cost based on what the best price would be? So if you're buying 1 bagel, what's the best price? Yeah, do they really have another option? No, so that's pretty easy. What about 2 bagels? How much does it cost?
280,
3 bagels,
275,
4 bagels,
$5,
5 bagels,
$6.25,
6 bagels.
$6.
All right, so if you're trying to buy 5 bagels, you're really better off just adding an extra bagel and paying less, right? Yes, no?
Yeah.
Yes, so consider that. Here's kind of like where you'd start to break it down differently. What about for 7 bagels?
$8.75.
It's not what I got. $7.25 would be the best price. Cause what's the breakdown? 1 for $6. And then that extra one at the single price is a 7.25. All right, 8 bagels. $8.50, good. 9 bagels. Good, because again, they have a special once you buy 9 or more. What about 10 bagels? All right, good. 9.25, 11 bagels. 10.50, 12 bagels. $10. All right, and then lastly, 13 bagels. $11.25. So the math that you had to do kind of for each section was a little bit different, right? For like 1 through 5, it was basically the number times 1.25. For 6 through 8, it was, I don't know how else you could describe it. Like if the number was X that you're buying, you would subtract the 6 and then times that by the 1.25 and add it to the special price. So like the math you were doing was slightly different at each time. What that kind of ties into are what we call functions. So they're relationships between numbers that are consistent. So if we were to graph this, this might be what it looks like. So in the first graph, the solid blue dots represent the shopkeeper's price. The circles would represent Jada's price. The red squares represent Priya's price, and the yellow triangles are Han's price. In the second graph, each X represents the best price for each number of bagels. All right, so keep that in mind. Are these graphs printed on your paper too, like on the other side? Okay. So then we will keep going because I think what they're going to want to make you do is use these as kind of like a model for this next piece. But first, let's formally define a function. I try to provide a glossary for each unit in Schoology. Once that is ready, it'll be right at the top of the Schoology page, linked for Unit 4. And this is actually already printed on your paper. So if you look on the bagel side again, a function takes inputs from one set and assigns them to outputs from another set, assigning exactly one output to each input. So that's like the formal definition. I have an easier way of remembering it. But for you guys, is there another way that you could say it? So read it again. Don't say it yet out loud. But how else can we say exactly one output to each input? All right, now discuss in your groups. Is there a special way that you can remember that isn't this? All right, so if you have a good way of restating that underlying part, exactly what output to each input, what would you guys say? Everyone? So think about like when we did graphing. What are our outputs usually represented by? Okay, so which one, the X or the Y? So I think most of our graphs are in the form y equals mx plus b, or could be rearranged into that form. Which one is usually our output? So y, because it's usually our total of some sort, right? So then the y is usually our output, which means what is usually our input? The x. So in other words, you could say exactly one y to every x. All right, that's one way to say it. My favorite way to say it is no repeating x's with different y's. All right, no repeating x's with different y's. Sometimes you enter a data point in, so you put another input in again, but you still get the same output. So if it's a function, like an equation, something that you're performing on the input, you should never get a different output if it's a function. All right, so in this example, and I don't know if it's on your paper at all, but you can just look on the screen. Don't yell out the answer. So which of these sets would not be a function then? So think about it, look at it, it's not on your paper or anything. A little bit longer. All right, raise your hand if you think that A is not a function. All right, Alex, why do you think that? And the one is in what position? And they have different y's, correct? So that is why set A is not a function. So if you want to put an example of what a function is not, you could put set A as an example, because it has the same x with two different y's. Could B or is B a function, yes or no? All right, why is that? Each x is different. So if in your function they give you each x is different, you automatically know that yes, it is a function. All right, those are usually my favorite because you can just stop there. What about in set C? All right, what makes it not a function? The -1 in the x spot connecting to a 2 and a 3. All right, so there was actually 2 that were not functions. Questions on figuring that out? All right, you should not have any repeating x's. If you do, it better be the same one. All right, so moving on then. 3 days in a row, a dog owner tied his dog's 5-foot leash to a post outside a store while he ran into the store to get a drink. Each time the owner returned within minutes. The dog's movement each day is described here. So day 1, the dog walked around the entire time while waiting for its owner. Day 2, the dog walked around for the first minute and then laid down until his owner returned. Day 3, the dog tried to follow its owner into the store, but was stopped by the leash, started walking around the post in one direction. It kept walking until its leash was completely wound up around the post. The dog stayed until its owner returned. So each day the dog was 1.5 feet away from the post when the owner left. Each day, 60 seconds after the owner left, the dog was 4 feet from the post. Your teacher will assign one of the days for you to analyze. Sketch a graph that could represent the dog's distance from the post in feet as a function of time in seconds since the owner left. All right, so lots of words. Hopefully you guys know what's going on. If not, maybe your group can figure it out. So I'll just kind of walk around and assign you what day you are, and then you're making a function based off of that. So a function could be an equation. In fact, it usually is, with an X and a Y. That whenever you apply that function, you never get a X with a different Y value. It always makes sense, right? Okay, so I'm going to come around and tell you what day you are working off of. So there were some rules, I guess you could say. Each day the dog was 1.5 feet away from the post when the owner left. So if this is time after the owner left, the graph should start here, right? Anyone disagree with me on that? Because it was 1.5 feet away when the owner left. If this is distance away from the post and they were right at the start, the graph would start here. Each day, 60 seconds after the owner left. So here is 60 seconds. The dog was 4 feet from the post. So I can see how day 1 could be represented by that. If the dog walked around the entire time while waiting for its owner, so we could connect these 2 dots. But if they walked around the entire time, do we know like how close or how far he was away from the post? Yeah, he could have been like closer, could have gone farther, could have gone really close again, who knows? But it shouldn't this first part be the same on all the graphs that I highlighted? Yes, because that's what it said in the instructions. But this part is pretty ambiguous, meaning like it's open to interpretation. I just have to see that the dog walked around the entire time while waiting for its owner. So the plateau that we saw in that example, I don't know. It could be that he was consistently walking in a circle completely 4 feet around the post, I guess you could say at all times. But it kind of looks like he just laid down. So that would be like my only critique there, is make it look like a constant movement. But otherwise good. We had the main part that needed to be on all the graphs. So this could be open to interpretation. Any questions on that? All right, so we could just end the graph there. For day 2, let's see if I have any good examples on here for day 2. All right. So we have the same part that we're supposed to have, right? We said they start here, and when 60 seconds after he goes 4 feet away. Does that match the description we have for day 2? The dog walked around for the first minute, then laid down until its owner returned. All right, I agree. So you guys could copy that. That one I think is less ambiguous. If he's not moving from that spot, then it would look something like that. So even if you didn't have day 1 or day 2, make sure you're also writing that down. All right, let's see if we have a good example for day 3. That one had a lot more stuff going on. Do you guys think this is good, class? All right, I mean, it looks like this part matches what we said it would be for all the graphs, because that was the piece of information we had. For the, and I need to pull up the description. For the following its owner into the store, but stopped by the leash, that means that the leash would have to be fully extended or close to the post. Fully extended. Did it say how long the leash was? So the maximum it could be away really is 5 feet, correct? Okay. Let's see if that's on here. So really, to fix this, we might fully extend it up to 5 feet. And then it started walking around the post in one direction. So around the post in one direction. It kept walking until its leash was completely wound up around the post. So as it gets wound up, does it get close to the post or farther from the post? So as it keeps walking around kind of at a constant rate, it starts getting really close to the post until it can't go anymore. So I do think that was really good. It just needed to be brought up to the 5 mark. All right, questions on this activity? So let me go back. So sketch this. I'll freeze it for day 3, but fix it where it's like up to the red line. But otherwise, that's really good. For the last few minutes, instead of like continuing, you could open up your Chromebook and start your puzzle piece. There's still like one more page of notes we have to do, but we'll save that for Monday for this lesson. So put your note sheet in your binder. This will be for binder check. We call it number 4 because it's for unit 4, but this will be for your next binder check. I still suggest saving all your notes for your final exam. All right, and do not line up for anything.